Hello friends, welcome to IMS GATE Academy. My name is Sourav Upadhyay and I welcome all of you to this live session of the quick formula revision series. My dear friends, GATE is almost here and it is big time that we should start focusing on revising all the concepts that we have studied so far, memorized so far. All the PYQs, it's time to revise them, and it's big time that we do not practice or we do not touch any new question, any question from either XY test series, any big questions from standard textbooks. That means you are getting that we should not touch any new questions. It's time for complete revision. My dear friends, in this context only I am coming up, or I am here on the session of industrial engineering. My dear friends, talking on industrial engineering, weightage wise it will be carrying 5 to 6 marks or 5 to 7 marks, and these are some of the easy marks, and my suggestion is, or anyone's suggestion would be, to not leave those marks, to maximize the marks in this subject. So my suggestion will be to watch this session throughout, sit nicely, enjoy the session, and just see that what concepts are there in this chapter that you should strictly not miss. My dear friends, what can you expect from the session? As I said, or as the title suggests, that I will be revising this chapter. All the important formulas, all the important concepts, and no questions. Yes, question series already it has been done, right? Concept, the GATE booster series already it has been done 1 month back, and now this is for revision. So my dear friends, only 10 days hardly is left. So do not touch any new questions, just revise whatever you have learned and trust in yourself. So my dear friends, so Harshil is here, LPP, Subodh sir, good morning, Harshil, okay, Harshil LPP, okay. Now LP we will see, let's start first, we will see. So my dear friends, without wasting any time, let's quickly go to the subject. Oh, and one more thing, my dear friends, what chapters can you expect? Now, since Harshil told that LPP is there, so let me tell you, I will be starting with network models, all the concepts, then I will be going in inventory, then what? Queuing, then what? Forecasting, then break-even analysis, and so on. Now, LPP especially we will see, because it's a question oriented this entire chapter is, so we will just see that whether entire LPP is there or not. Anyway, let's see, let's start the session in the name of God. Now my dear friends, see, the first chapter that will be touching is network models. My dear friends, in network models, what is the first thing that we study? Critical path method, yes or no? CPM method, critical path method. Now see this diagram, see, for explaining few concepts I will be referring, I will be taking the help of few numericals also, so you should not forget that. Now this is a network diagram, all the information has been given, and based on that this network diagram has been drawn. Now just ignore the numbers, you tell me, it's like a discussion, Good morning Jagdish, good afternoon, yes. See, the first thing that we do in a network diagram is calculate 2 times for any nodes, and that is done with the help of forward pass computation, backward pass computation. Now in forward pass computation, what we do for reaching any node, now just listen very nicely, for reaching any node, suppose we are reaching with the help of 2 ways, we take the maximum time. So suppose there are 1, 2, 3, 4, 5, 6 nodes, so whatever number of paths are there for reaching these nodes, we will be taking the maximum time, and for again we have to come backwards and then we take the minimum time. So forward pass and backward pass. So at the end of forward pass and backward pass, above each node there will be 2 times, and those 2 times only are written over here. Yes or no? Those 2 times only it's written over here. Now let me explain you quickly. See, Suppose I have to reach node 3. So if you go by this path, 0 plus 6, one option is 6, and if you go by this path, it will be 5 plus 3, 8. So which is maximum? 8. So I have written over 8. That's it, maximum. Suppose over here, 8 plus 2 is 10, and if you go by this way, 8 plus 5, 13. So one is 8 and one is 13, so I have to take the maximum. So maximum has been taken. Here also maximum has been taken. And if you come back, you have to take the minimum. For example, suppose over here, suppose I have to reach node 4. So 25 minus 1 is what? 24. And if you come by this way, it will be 25 minus 12, it is 13. So we have to take the minimum, so I have written the minimum. So just remember one thing, going forward maximum time, coming backward minimum time, and at the end of this process, you will have 2 time estimates for each node. So I am erasing this one. Fine. Now my dear friends, after that what? The time in the numerator, let's say for I am considering particular node and its time is P by Q. Okay, forward pass is giving me P and backward is giving me Q. Forward pass is giving you the earliest time of completion of an event, and backward pass is giving you the latest time of completion of an event. I repeat again, this number P, it is in the numerator, it is giving you earliest to earliest your event will be completed when, and this Q is giving you latest to latest your event will be completed when. Now there should be some standard set, and that standard set is without affecting the project duration. So without affecting the project duration, earliest to earliest your event will be completed when? P. Latest to latest your event will be completed when? Q, but without affecting the project duration. So what is the project duration? 25. So for example, if I touch node 3 and if I ask you what is the earliest earliest possible time you can complete this event? 8. Without affecting the project duration, 25. Latest to latest, 11. And there is some relaxation period, yes or no? And that relaxation period is nothing but your slack, and that we call slack of an event. So what is the slack of an event over here? 11, 8 and 11 is there. So 11 minus 8, 3. Getting or not? So over here, if I say what is slack of an event, so it is Q minus P. Till now, whatever I have told, it is with respect to event. That's it. In event, they can ask only this much. Now comes the activity. My dear friends, when it comes to activity, let's focus on activity. Let's focus on a particular activity. This activity is E. So let me take it over here. When I'm talking about activity, you have to take this entire thing over here. This is 8, this is 11, and this is 13, and this is 13. My dear friends, in activity, there are 4 times possible. What are the 4 times? Let me write it over here. The 4 times is EST, EFT, LST, and LFT. Earliest starting time, earliest finishing time, latest start time, latest finishing time. My dear friends, we have to calculate all these 4 time estimates. Now suppose you have done forward pass and backward pass computation. Fine, good. Now remember always, from forward pass and backward pass computation, you are ready-made getting 2 times among these 4, and that is EST and that is LFT. For example, if I focus over here, so 8 is giving you the EST for activity E, and 13 is giving you the LFT, latest finish time, for this activity E. Now my dear friends, this 8 is what? See, EST is what? 8. LFT is what? 13. And my dear friends, if you add the activity time over here, so you are getting EFT, and if you subtract the activity time over here, you are getting the LST. So 4 times done, yes, Ready-madely we are getting 2 times. You add activity time, you will be getting EFT, and you subtract activity time, so you will be getting LST. So 4 times we have got. Yes or no? 4 times we have got. Now, let's check. Let's find the float for this activity. Let's find the float for this activity. Eight, 11, 13, 13. 8, 11, 13, 13. My dear friends, it's time to calculate the total float for this activity. My dear friends, just remember one diagram and then job is done. What is that diagram? See, this is that diagram. This is that diagram. Done. What we have to find out? Total float. So what is total float, my dear friends? Total float is 13 minus 2 minus 8, and that is nothing but 3. Done. No formula. No formula. Just remember this diagram, it's done. They can ask you what is free float. They can ask you what is free float. What is free float? Free float is total float minus head event slack. So total float is what? 3, and head event slack is what? 13 minus 13. Head event slack. Slack for head event. For an activity, this is the head event. So 13 minus 13, 0. So it is 3. They can ask you what is independent float. What is independent float? It is free float minus tail event slack. So free float is what? 3, and tail event slack is what? 11 minus 8, 3, 0. Right? So my dear friends, slack for an event, float for an activity. Fine. Slack for an event, float for an activity. Now my dear friends, this slack and event we have found for this slack and float we have found for event and activity. Now there will be some activities whose float will be 0. If total float is only 0, good afternoon Nikhil, if total float is only 0, so free float and independent float will have to be 0. So we have to identify that which activities are there whose total float is coming out to be 0. They will be lying on a particular path. So those activities will be called the critical activities, and the path on which they are lying, it will be called as critical path, and the summation of the times of the critical path is called critical path duration. Yes or no? So in this case, if you identify, now just focus this diagram, just focus this arrow, activity A, D and H. If you calculate the float for these, if you calculate the slack for these, everything will come out to be 0. That means they are critical in nature. They cannot be, they cannot be altered. They are strictly that if activity A is to be finished within 5 days, so it has to be finished within 5 days. There is no relaxation for such activities. Everything will if you calculate it, you will get it to be 0. So such activities are called critical activities, and the path in which they are lying is called critical path, and the duration of this path is critical path duration. Fine. So if you add all the paths, so 8 plus 5, 13, 13 plus 12, 25 is your critical path duration. Now you will be asking me that, sir, if we go on by this method in examination, it will be taking a lot of time. Yes or no? So my dear friends, to avoid this lengthy calculation, just see that in your entire network system, which path is coming out to be the lengthiest path, and that automatically becomes your critical path duration. For example, over here it was 1, 3, 5, 6 one way of reaching, 1, 3, 6 one another way of reaching, 1, 2, 4, 5, 6 third way of reaching, and 1, 2, 4 and 6 fourth way of reaching. 4 ways were there of reaching from starting event to ending event, and whatever is your lengthiest path, that becomes your critical path. So my dear friends, in critical path method, let me recap. Whatever I have told in this 10 minutes, let me recap. There will be network system, it will be given to you. See, precedence relationship will be given to you, activities will be given to you, and duration of those activities will be given to you. Fine. So based on precedence relationship, you will be plotting the network diagram. Number one. Here I have done that for you for time saving. That's different thing. But in examination you will be given, you will have to draw by yourself. So first job is what? Drawing the network diagram neatly, nicely, accurately, avoiding the use of dummy activities, like as much least dummy activities as you can use. Secondly, see, for finding any slack, any float, any EST, these 4 time estimates, anything, you need to do what? You have to find, you have to do forward path computation, backward path computation. For every event, on the top of every event, you will be having 2 time estimates. Now, if they ask you for event, they can ask you 2 things. What? Earliest occurrence of an event, latest occurrence of an event, and slack of an event, of course. For activity, they can ask you these 4 types of time: EST, EFT, LST, LFT, and finally what they can ask you? Total float, free float, independent float. This is all about your critical path method. Any doubt, my dear friends? Any doubt? Any doubt? So I guess no doubt is there and you have understood everything. Now let me take you to the next part of this discussion, and that is PERT. Let me take you to the next part of this discussion, and that is PERT, Program Evaluation Review Technique. My dear friends, can anyone tell me that why I have drawn this diagram, normal distribution, when it comes to PERT? Can any one of you tell me that why I have drawn this normal distribution diagram when it comes to PERT? Okay, I'll tell you. See, in PERT, we do not know the time of the activity. That is why for finding the completion time of an activity, we need 3 time estimates. Yes, because time is probabilistic in nature, when we are doing the project for the first time, like in research project, missile launching, any anything, space launching, anything, we do not know how much time it will take. Anything we are doing it for the first time, for let's say COVID vaccine manufacturing, anything we are doing it for the first time, so it will require some research work and we do not know how much time it will take. That is why we use the reference of 3 time estimates. What are the 3 time estimates, my dear friends? So let me tell you. The 3 time estimate is optimistic time, pessimistic time, and your most likely time, and they follow beta distribution. They are beta distributed. It is T0, it is TP, and somewhere here it will be most likely time. What is T0? Early to early you can complete the project, you complete the activity, that is T0. Latest to latest you can complete the activity, that is TP, and the average time in which you can complete the activity is the most likely time. Okay. They are what? Beta distributed. Beta distribution. Now my dear friends, using this time estimates, we have to find what? Most expected time, or the expected time for an activity. Now tell me one thing, expected time. Expected, say what comes? Expectation. In maths you have studied expectation is what? Summation x into px. Yes or no? Summation x into px. So 1 by 6 into T0 plus 4 by 6 into Tm. Most likely, see, most likely, that's why I have assigned it higher weight, plus 1 by 6 into Tp. So the formula becomes what? T0 plus 4 Tm plus Tp divided by 6. This is what? Your expected time for an activity. Now suppose in a project, if there are 5-6 activities, for each activities you will be able to find out the expected time. Number 1. Number 2, standard deviation. What is standard deviation, my dear friends? The range. Basically the range is nothing but it becomes your standard deviation. So standard deviation for an activity. What will be the variance for this activity? Variance for this activity is what? Standard deviation square. Yes or no? So for an activity, my dear friends, we are able to find expected time, standard deviation and variance. Now suppose, my dear friends, this is a network diagram. Let's say this is a network diagram. One, two, three, four, five, and these are forming your, this is forming your critical path. So what we can do, my dear friends, using the three time estimates, I can find the expected time for this, expected time for this, expected time for this, and if you add all the expected time of the activities lying on the critical path, you ultimately get the expected project completion time. Number one, you get what? Expected project completion time. Let me assume it is T. Second, if they ask you what is the variance of this project, so what do? You know that variance is, if we can add variance, we cannot add standard deviation, but we can add variance. Yes or no? When we can add variance, so the variance of the activities lying on the critical path, if you add all the variances, you will get what? Variance of the project. Yes or no? But you need standard deviation. So ultimately I have to take the square root of the variance, then only I will be getting the standard deviation of the project. Getting or not? So suppose first I will be, suppose this is A, suppose this is B, suppose this is C. So what will be the sigma square of this project? Sigma A square, sigma B square and sigma C square. And ultimately if I ask you what is the standard deviation of the project, so you will be taking the square root. So like this we have got the expected project completion time and the standard deviation of the project. Getting or not? So thank you for your kind words, Pragya sir. Thank you. Thank you a lot. So my dear friends, in PERT we have reached two things: expected project completion time and variance. And now I am taking you to my first question, that why I have shown you this normal distribution curve. Now can anyone tell me that why I have shown this normal distribution curve? I have given all the hint. See, I have shown this because the expected project completion time in PERT is normally distributed. I repeat, what? The expected project completion time in PERT is what? Is normally distributed. Now my dear friends, remember you have found here what? T. See, expected project completion time is what? Expectation means what? The average value. The average value. Let's say this is T, and my dear friends, this is nothing but your T over here, the mu, right? Sitting in the middle of the curve, it is nothing but your expected project completion time. Now the moment I have shown this thing by help of what? Z, standard normal distribution. Okay, standard normal distribution. Now tell me one thing, my dear friends, the moment I place mu over here, and if you know the properties of normal distribution, immediately you can tell me that, sir, the probability of completion of the project within the expected time is 50%. How? Because area under the z value, any z value, area under the normal curve, it gives you what? Probability. Area under the normal curve between any two values gives you probability. So suppose this is mu, and if you shade this area, you know, by symmetric property, It is what? 50%. This area is what? 50%. So I'll be able to tell that the probability of project completion within the expected time is 50%. Now the moment I do this, you will be asking me that, sir, can we do that for any z value? Yes. Getting or not? Yes. You can do that for any z value, but I am saying z value, not x value. Now you are confused over here. Sir, why are you saying z value and why are you saying x value? My dear friends, see, z values are in terms of 1, 2, 3, 4, 5, 6, 7. But the project completion time that you have calculated over here, it can be 50 days. It can be 50 days. So suppose if someone asks you what is the probability of completion of the project within 50 days, you are referring this curve and you are saying, sir, 50 days means z equal to 0, and you shade the area 50% done. And suppose if someone asks you what is the probability of completion of the project within 60 days, then you will do what? Then you will do what? For that reason, my dear friends, you have to convert it to z value. You have to convert it to standard normal distribution. Initially it is your normally distributed, and when you convert it to z value, you get standard normal distribution. Standard, these are the standard values. Now how to convert? How to convert? See, you know this thing that how to get the z value. First of all, how to get the z value? So z is x minus mu by sigma. Yes or no? X is, let's say, any random x value you have, let's say 60 days. Mu is the expected project completion time, let's say 50 days over here. And sigma is what? Sigma is the standard deviation of the project. Standard deviation of the project. I told you na, standard deviation of the project. You know all these values from your network diagram, this mu and sigma, and x value, let's say 60 days. So suppose that mu is 50 days. Sigma is, let's say 5. Sigma is, let's say 5, let's say. And x you want to calculate for 60 days. You want to know that, sir, for 60 days, what is the probability of project completion? So what I will do? Immediately I'll find the value of z, that is 60 minus 50 divided by 5. So it is nothing but 10 by 5, and it is nothing but 2. So immediately you will see over here that where is z equal to 2? Okay, here is z equal to 2. And sir is asking me that, the question is asking you that what is the probability of project completion within 60 days. So it means 0 to 60 na, from before 60, 0 to 60. So 0 is here, somewhere around here. Don't take z equal to 0. Don't take z equal to 0. 0 is somewhere around here, 60 is somewhere around here. So you simply find the area of this. Simply find the area of this. Getting or not? Now since z equal to 2 corresponds to a standard value, I know that the area between minus 2 to 2 is 95.4%. Minus 2 to 2, area is 95.4%. So you have to add some extra area over here, that is fine, that we can do it. But are you getting the concept or not? Now my dear friends, the thing is, this was the example that I took, it was something of a standard value. Everyone knew the value. But what suppose you get z equal to 1.5? What if they give you, they are giving you, asking you a time, and z equal to 1.5 you got by this? Then what? The question is, then what? Then my dear friends, the examiner has to give you the standard normal distribution table, where he will give you that for z equal to 1.5, area corresponds to this. So looking at the table, you have to find the area. But ultimately you should know that between any two z values, area under the normal curve is giving me probability. Only this much concept is required, and rest you can do any question, my dear friends. Is this concept clear? Is this concept clear, my dear friends? So far they have not given you a question where you require the standard normal table, but they can give you in future. So I hope this concept is clear, my dear friends. The concept of PERT is clear. So till now, my dear friends, we have discussed two concepts, and that is CPM and PERT. And definitely I will say that one question will be there from whatever we have discussed, right? So I hope that things are clear till now. Now, my dear friends, one more concept is there, the concept of crashing. The concept of crashing is there in your network models. Now see, generally when you practice numericals related to crashing, then only it becomes clear. There is no as such any formula, big formula is not there, but let me discuss anyway that what is the concept. I am only talking about the concept. See, crashing means they can ask you two things in crashing. They can ask you two things in crashing. One is the minimum time and one is the optimum time. What is the meaning of optimum time? Optimum time means the time till which you will crash and you are getting the lowest cost, least cost. And what is minimum time? Minimum time is the time till which you can crash the project irrespective of the cost. These two things they will ask. Now in crashing, my dear friends, you should remember that we always crash the critical path. We always crash the critical path. Fine, number one thing. Number two, we crash only those activities whose cost slope is the least. Whose cost slope is the least. I'll tell you what is cost slope. And number three, what is the first step? The first step is, my dear friends, when you get a network diagram, you will have to see that which is your critical path and which is your not critical path. Suppose critical path is 15 days, non-critical path is 11 days, and they are asking you to crash by 3 days, let's say, for example. So in this case, you are not concerned about the second critical path. The first critical path is 15, second is 11, difference is 4. So easily you can crash the critical path to 3 days without worrying about the second critical path. And obviously we will crash only those activities whose cost slope is the least. I'll tell you what is cost slope. Now suppose in this case they are asking you to crash by 5 days. What is the difference? 4 days. And now they are asking you to crash by 5 days. So what you will do? For the first 4 days, I can easily crash the critical path. From 15 to 11 I will come. And for the next 1 day, now you have two critical paths. So I will have to crash both the paths. Then only the entire project duration will come down. Now easier said than done. I have only told you the concept. I hope you are able to relate it with the formulas, or with the, when you are solving the questions, you will be better able to understand. And I have taken this question in my concept booster series as well, right? So there are some of the PYQs, and you can definitely practice that. Now let me tell you what is cost slope. Suppose, my dear friends, for an activity A, the normal project duration is 10 days, and after crashing it is coming down to 5 days. The maximum time till which I can crash is 5 days. Now corresponding to normal cost for this activity, the normal cost, corresponding to normal time, the normal cost is, let's say, 1000, and the crash cost, obviously when you crash an activity, the cost increases, so it is becoming 2000. This much information for an activity will be given to you in case of a problem. So if you plot it, my dear friends, here I am taking the cost and here I am taking the time. See, Tn is more, so I will plot over here. Tc is over here, it will be what? Now here it is cost, so Cn, and here it will be Cc. So one point is over here, TCCC, and one point is over here, TNCN. If you connect both, are you getting a negative slope? Yes or no? We are getting a negative slope. So if I ask you what is the cost of this line, what is the slope of this line? What is the slope of this line? So you will tell me, sir, slope is what? dy divided by dx. So what is dy? Cc minus Cn divided by Tn minus Tc. And this, my dear friends, is nothing but your cost slope. It is what? Cost slope for an activity. For an activity. Now what does cost slope gives, my dear friends? Cost slope gives you the increase in cost when you crash an activity. And that is why, when suppose there are 5-6 activities given to me and I found the cost slope of each of the activity. So I will crash only that activity whose cost slope is the least. Getting or not? Getting or not? So this is the concept of cost slope, and rest, my dear friends, I have told you what to do in crashing, and rest you will be able to understand with the help of a question that is suited better in that way. So till now, my dear friends, in this 45 minutes, I have revised one chapter, and that is your network models. In network models, you can expect questions from where? From CPM, from PERT, and from crashing. Only these three topics are there. And now, my dear friends, it's time to move on to the next chapter, and my next chapter is nothing but inventory. The next chapter is nothing but inventory. The next chapter that I am going to discuss is what? Inventory. So I hope till now there is no doubts, my dear friends, and you can obviously ask if any doubt is there, right? And let's discuss inventory. So just a minute. Fine. My dear friends, inventory is very important. Everyone must be knowing. And when it comes to inventory, we divide it in two sections. What are the two sections? One is deterministic models and other is probabilistic models. Very, very important, my dear friends. Everything is very important in inventory, and that is why I started with the most important of chapters. That even if you watch for, let's say, 2 hours, you will be getting the feel of all the important chapters. Nonetheless, I should not say that every chapter is important and questions can come from anywhere in this uncertain era. Now, my dear friends, before talking of this model, before talking of deterministic model, before talking of probabilistic model, let me talk about the type of cost in inventory. Now, what are the types of cost in inventory, my dear friends? The types of cost is, can anyone tell me? See, for an item, there will be unit cost. Matlab, cost of an item. Then there will be ordering cost. Yes or no? Then there will be holding cost. Then there will be shortage cost. Now units are also very important. We cannot simply ignore the units. See, cost of an item is what? Per unit is, it will be just simply rupees 5 per item, something like that. Fine. Ordering cost, cost per order, that is C naught. Generally it is represented by C naught, per order. See, in an order you can when you place an order, you can order something like any number of items. So not really dependent on the items, per order it is there. Holding cost. See, holding cost, when you are carrying something, you need to rent a space for a particular amount of time. That's why when it will be something like rupees CH per unit, because more the number of units, more will be the space that you will rent, and that time is also there. For 6 months you will rent something, for 1 year you will rent something. So CH per unit per time. It's something like rupees 2 per unit per time, per year, okay, or per month or per day, anything. And similarly for shortage cost also there will be CS per unit per time. So this is all about the the types of cost. Setup cost is also there, and its nature is similar to ordering cost, and I'll talk about setup cost when I reach the suitable model. Now my dear friends, coming to the deterministic model. What I told? Deterministic model. Why deterministic? Can anyone tell? Why deterministic? Because the demand is certain. We know that in a particular year I need 12,000 units. In a particular year I need 10,000 units. In this month I need that much of unit. It is all certain. That is why the name is deterministic model. Now, the first is basic EOQ model or Wilson-Harris model, my dear friends. This is the basic one. The good thing is that questions regularly come from this basic model. And for the upcoming models also questions come. So that is a good thing about that, right? It's not like that basic model is there so question won't come. Anyway, my dear friends, what is the total cost? See, I'll tell you one thing. In any model, just remember one thing, we have to minimize the total variable cost. That's it. I repeat again, for any model, what is the underlying concept? The concept is we have to minimize the total variable cost, and whatever expression we get from there, that we use as an expression. See, in inventory, everyone knows that it is very much important to remember the formula. You remember the formula, you go to an examination, you sit. I can write the formula over here also, that's not the problem. But the thing is, you should at least have an idea that from where they are coming, just a basic idea, so that even if they ask you a some question from within the diagram, so you should be able to answer. Now my dear friends, what is the total cost or total variable cost over here? Here it is, in this basic model, it is nothing but ordering cost plus holding cost. Okay, it is nothing but number of orders into C naught plus average inventory into holding cost. What is number of orders? Number of orders is annual demand divided by ordered quantity multiplied by C naught plus what is average inventory? See, always remember, in average inventory, whenever we want to find out, it will be total area divided by the cycle time. Now cycle time is till here only, ignore this. Total area divided by cycle time. What is the total area, my dear friends? See, total area till which inventory is there. What is the total area? Total area is, let me write it over here, half into T into Q, and cycle time is what? T into CH, D by Q into C naught plus T and T gets cancelled, so Q by 2 into CH. Now my dear friends, this is the total variable cost, and if you want to obtain the expression, see I already told that we have to minimize this total variable cost, yes or no? So if you minimize this total variable cost with respect to what is the variable? The variable is q over here. So d of q, and if you equate it to 0, my dear friends, when you equate it to 0, you know what we are going to get? Everyone knows this, yes or no? We are going to get q star, and that is nothing but root over 2d c naught by ch, and that is the formula that you have to remember, and you remember, I know this, you remember, everyone remembers this. Now my dear friends, the only important thing I will tell regarding this formula is ch and d. D is the, let's say, annual demand, that means per year. So ch unit should also be per year only. Suppose this is monthly demand, so ch should be cost per month. Daily demand, so per day. That's it. The unit should be consistent, then only it will give you the correct result, yes or no? Now my dear friends, you know that this q star, if you substitute over here, and if you substitute over here, and if you substitute over here, so you will be getting what? Total variable cost minimum, and its formula everyone knows, it is 2d c naught and ch. Okay. One observation is this: ordering cost becomes equal to holding cost. So if you divide it by 2, you will be getting, this, yes or no, and this. So that is the value of ordering cost, and the same is the value of holding cost, and that becomes equal. So always remember, ordering cost equal to holding cost is an observation, is a result of EOQ. We cannot directly equate this and get the expression of EOQ. So this much is necessary, my dear friends. And of course, if they ask you the cycle time, you can write na, Q is equal to demand into TC. My dear friends, it's very important to use the triangles effectively for in your advantage, right? Always remember the triangles. So I'll not waste much time over here, simply coming to the next model, and that is the shortage model, my dear friends. That is the shortage model. My dear friends, see, I'll be starting with only one concept. And that concept is that what is the total variable cost, my dear friends? Total variable cost will be ordering cost. Okay, let me not write over here. See, total variable cost is what? Ordering cost plus holding cost and plus shortage cost is also there. What will be ordering cost? Number of orders into ordering cost. What is holding cost? Holding cost is average inventory into CH. And what is shortage cost? Average shortage into CS. So question is how to get average inventory and how to get average shortage. I already told you that average inventory is what? The total area of inventory divided by cycle time. Yes or no? And this is what? Total area for shortage. Total area for shortage divided by cycle time. Yes or no? So what is now come to over here? what is the total area for inventory? The total area for inventory, see this triangle is there na? Are you able to see? Only this triangle is there na for inventory. Only this triangle is there na. So what will be there? It will be half into T1. See this is T1. For T1 period inventory is there. So it will be T1 into IM whole divided by the total cycle time. So thank you Ankit for your kind words. Thank you. So this is the average inventory. This is the average inventory. Getting or not? And when it comes to, so let me write it. See, T1 by T, this is fine. This is the average inventory. But my dear friends, what about T1 by T? What about this thing? I'll tell you one more thing. Suppose if you want to find the average shortage, so what do? You calculate the area for this, that is half into T2 into S, and by total area is what? T. So what about this? What about this? And what about this? How to use? So that is why I tell you that always make use of the area of the triangles. Now my dear friends, tell me one thing. How many triangles we can see over here? See, using the bigger triangle, what I can write? Using the bigger triangle I can write Q is equal to D into cycle time, number 1. Okay, cycle time I have taken T over here. Okay, now this triangle, what I can write? IM is equal to D into T1, yes or no? Now using this smaller triangle, what I can write? S is equal to demanded into, yes or no? And finally I can write what? Finally I can write Q is equal to IM plus S, yes or no? Getting? Using the triangle only I have written these expressions. Now I told you what is T1 by T. So just divide it, T1 by T. Just divide it, 2 by 1. So T1 by T becomes what? IM by Q. Done. Done. What is? Over here it was T2 by T. So T2 by T is what? T2 by T is, just divide. It will be S by Q over one expression over here, another expression over here. You substitute over here. Are you getting or not? You substitute over there, it will be what? If you substitute, it will be IM by Q. That means IM square by 2Q. And over here, if you substitute, it will be S square by 2Q. Are you getting or not? So, my dear friends, D by Q into C naught plus it will be IM square by 2Q into CH and plus S square by 2Q into CS. And now my dear friends, this is the expression for your total variable cost. Getting or not? And finally you know one thing, that we have to differentiate. Now I will be asking that sir, there are 3 variables Q, IM and CS. Q, IM and S. Now one more expression is there. And from here what I can write? In place of IM I can write Q minus S. In place of IM, see, in place of IM, okay, I am not disturbing this. IM is equal to Q minus S. And when you substitute this, you will be getting in respect to 2 variables. Fine. You will be getting answer with respect to 2 variables. And if you differentiate this, now my dear friends, see, now you have to differentiate the total variable cost with respect to one's S, put it equal to 0, and you have to differentiate with the total variable cost with respect to Q, put it equal to 0, you will be getting one expression. Two variables, two times differentiation. And when you differentiate finally, my dear friends, that result you will be remembering. Getting or not? That final result you will be remembering. So how much time did I took? 5 to 10 minutes, and this much also you need to remember. So can anyone tell me the result? Can anyone tell me the result? What is the result? Yes or no? This we will get. Now in terms of Q star, what we will get? In terms of Q star, 2D C naught by CH into CS plus CH divided by CS. See, CS is the shortage cost. CS is the shortage cost. And finally, my dear friends, the maximum inventory level, you can do two things. You can do two things over here. You can first subtract Q star minus S star, or you can remember directly a formula. You can directly remember a formula, and that formula is Q star into CS by CS plus CH. Make it Q star over here. That's it. That's it. And finally, my dear friends, you will be asking that, sir, where is total variable cost minimum? Total variable cost minimum, my dear friends. Total variable cost minimum. So what we have to do? Just remember that whatever factor I have written over here, simply reverse in the total variable cost. So total variable cost minimum is nothing but 2D C naught by CH into just reverse CS by CS plus CH. That's it. Only this much formula you will have to remember from this model. But as I said, how they are coming, it is also important. How they are coming, it is also very much important. So is this model clear, my dear friends? Is this model clear? And just before winding up this model, why I was saying that triangles are important. Suppose they ask you that what is the shortage time. Suppose if they ask you what is the shortage time and you remember this triangle, so you can directly apply this formula, na? You can directly apply this formula and get. Suppose they ask you that till what time inventory is there. So what you can do? You can use this formula. Okay, IM is equal to D into T1. That's it, done. Calculate T1. What is the cycle time? Use this expression, get the cycle time. Getting or not? Getting or not, my dear friends? So this was all about shortage model. This was all about shortage model. All about shortage model. And now, my dear friends, the third most important model. See, all these models are very, 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 very important. And you also know this. Questions regularly come from these models, deterministic models. Now, my dear friends, production consumption model or the manufacturing model. See, as I said, I'll require only 5 minutes, to write the important points, and finally I will write what is the formula required. What is the thing, my dear friends? See, first of all, how many types of cost will be there? Setup cost, holding cost. See, in place of ordering, in this we do not order, we build by ourselves. Yes or no? Self-sufficient. So we will manufacture the thing, we will hold it, that's it. No shortage is there, right? So what is the total variable cost, my dear friends? Setup cost plus holding cost, number of setups into setup cost plus average inventory into CH. Average inventory is what? Total area of inventory divided by cycle time. Total area of inventory is what? Total area of inventory is what? Half into, what is the average inventory, my dear friends? Total area is half into cycle time into IM divided by the cycle time, and that is nothing but Im by 2. So it is nothing but Im by 2. Yes or no? So d by q into CSP plus Im by 2 into CH. Getting or not? Now, as I said, we have to utilize the triangles in the best possible way. So tell me one thing, can anyone tell me, if I use the bigger triangle, I can write na q is equal to cycle time into the demand rate. Okay, it is small d, I can write capital D, no issues with this. No issues with this. Suppose this triangle for the time you are only producing, so I can also write na q is equal to production rate into T1. Getting or not? Now focus on this triangle. Focus on this triangle. What you can write? You can write Im is equal to P minus D into T1. Yes or no? And my dear friends, this triangle, now this triangle is, Im is equal to D. See, the demand rate is D. Okay, I have taken capital D, no issues. I have taken capital D. So let me make it small d, my dear friends, no issues. Let me make it small d. It's small d, so let me make it small d, no issues. So small d into T2. Small d into T2. Done? Done? Over? Over. That's it. That's it. So using these relationships, you can find out so many things, my dear friends. If they ask you what is T1, if they ask you what is T2, if they ask you anything, cycle time, you will be able to calculate so easily from here. Now, my dear friends, can we find one thing? Can we find one thing? See, over here, just see relationships 2 and 3. Just check relationships 2 and 3. Just check relationships 2 and 3. If I write Im by Q, it will be what? P minus D by P, and T1 gets cancelled. So Im is equal to Q into 1 minus D by P. Q into 1 minus D, 1 minus D. So can I write this thing D by Q into CSP plus, in place of this Im, what I can write? In place of this Im, I can write Q by 2, 1 minus D by P, and into CH. Why I have done this? Because initially there were two variables, Q, Im, and now I have converted this Im into Q. And now, my dear friends, if you differentiate this entire TVC with respect to this Q and put it equal to 0, you will be getting the expression that you always memorize. And what is that expression, my dear friends? What is that expression? Yes or no? 2D CSP by CH into P by P minus D. Over. That's it. That's it. And as I told you that what will be total variable cost minimum? Total variable cost minimum. What is the logic that I told you? Simply reverse this factor. Simply reverse this. So 2D CSP by CH, and simply reverse this. That means P minus D by P. Over. That's it. Sirs, are you getting or not? Only I am using 5 minutes making use of the triangles. It's almost kind of deriving in front of you. It's almost kind of deriving, and I am not taking more than 5 minutes. So I request every one of you to, yes, memorize the formula, memorize the important formula that is written over here, but at the same time don't forget the triangles. They are your good friends. They will only help you in calculating some, inside details which is not possible with the help of formula. So these are the three important models. One more model is there, production consumption with shortage, but I will not discuss right now. I will keep it for the end. And even if I don't discuss over here, you know how the things will come and what is the final formula, you will already memorize that. That is not the big deal. And let me now, my dear friends, discuss the more important things, that is the probabilistic model. Probabilistic model is also very important, and there are some very important concepts in probabilistic model. So let me discuss first probabilistic model, my dear friends, right? Just a minute. Okay, some discount model is also there, but okay, discount model is there, but this is okay. Before going to probabilistic model, let me tell something about discount model. Although it is similar to crashing, you have done the problem, so it becomes very easy for you to understand. And in my concept session also I have taken one such example. So my dear friends, for any questions, please watch my concept booster series on industrial engineering. I have taken some of the best questions available. This type of discount model also I have taken over there. As of now, in discount model, what you have to remember? You have to remember that always start from the least unit price. Suppose I am just giving you an example. This is Q and this is your unit price. Suppose less than 1000, the unit price is rupees 6. 1000 to 2000, the unit price is 8, and greater than 2000, the unit price is 10. And what they are asking? What they are asking you the optimal order quantity. They are asking you the optimal order quantity. Yes or no? They are asking you. See, this is only possible na? In discount model, this is only possible. So something similar to this graph. See, this graph is not very much clear, I agree, but you know what I am trying to show over here. You know what I am trying to show over here. Something, this price break. See, price is breaking, that's why it is called price break model. Now, coming to the important thing, I am saying that, sorry, I have, see, what is the basic mistake I have written in my example? That when I am increasing the units, when I am increasing Q, P should come down, na? P should come down, na? So let's say this is 10, this is 8, and this is 6. We order more quantity. The shopkeeper says you order more quantity and the unit price comes down. I will give you for discount. Yes or no? Anyway, so what I was telling is that we always start from the least cost. I will always consider that one more thing. See, even in this you will have two cases. Even in this you will have two cases, when your holding cost is fixed and when your holding cost is expressed in some I percentage of the unit price. Get yes or no? Yes or no? Let's say in any case, let's say unit cost is fixed. The concept is same for any case, but let's say unit cost is fixed. So I will now I will always start from the least unit price. least unit price. See, when your holding cost is fixed, it is independent of unit price. Fine. So let me take this case when it is depending with respect to unit price. Okay. So suppose it is depending with respect to unit price. So I will consider 6 first. I will put 6 over here, find CH and find what is Q. The idea is we have to find what is Q first. And let's say, assume that this Q is falling in this range. This is satisfying in this range, my dear friends. That is satisfying. Let's say the Q is something around 2500. It is satisfying 2500. So immediately you will not go above and you will write your answer as what? 2500. Done. Sir, why? Because you know that this will be, let's say this is 10, this is 8, this is 6. So you know that optimal order quantity, that is Q star, is the lowest point for any curve. Immediately that becomes your answer. Yes or no? But it doesn't happen. It may happen. See, if it happens, you need not go above. That is your answer. But it doesn't happen always. Let's say it is falling in this range, or let's say that is not satisfying this. So what do? You immediately go up. You immediately go up. That means for the unit price of 8, again you do the same thing. You calculate CH, find EOQ and see whether it is falling in this range or not. Let's say now it is falling in this range, and now your EOQ has come out to be 1500. Now your EOQ has come out to be 1500. So what should you do? What should you do? Should you write 1500 as the answer? No. 1500 is not your answer. 1500 is one point of consideration, and the point from where price break is happening, that is another your point of consideration. So now you have to play between, or you have to compare between 1500 and 2000. 1500, 2000. Getting or not? 1500 and 2000. Now next question. Sir, do we need to go above? Do we need to check for 10? No. The moment your EOQ falls in this range, you need not go above. That's it. Getting or not? That's it. So finally, when you compare 1500, 2000, whatever is your, now see, after getting the points of consideration 1500 and 2000, you will have to find the total annual cost. Game is not done yet. You have to calculate the total annual cost, and for whatever quantity your TAC comes out to be least, that becomes your answer, optimal order quantity. And if you have practiced numericals, everyone will be getting what I am trying to say. I am trying to connect. So thank you, Sandeep sir, for your kind words. Really honored. So this is the concept of discount model, my dear friends. This is the concept of discount models. And without wasting any time, let me come to the probabilistic model, my dear friends. Probabilistic model. Just a minute. Okay. See, if you have studied probabilistic model, my dear friends, there are two models. There are two models in probabilistic model. What are those two models? The two models are, one is already written, the demand profit model, newspaper boy model, and another is the service model. And I am sure that all the students face confusion, face problem in service model. So if you just watch this 5 minutes information on service model, everything will be crystal clear. That is my assurance. So what happens in demand profit model, my dear friends? In demand profit model, you have to memorize only one inequality. Only one standard inequality is there. You memorize that and you go to the examination hall. What is that inequality? Profit by profit plus loss, probability for the optimum stock, and probability for S minus 1. You memorize this inequality, you go to the examination hall, as simple as that. See, how to get all these things, I'll tell you, don't worry. This is profit and this is loss. So everyone has studied profit loss, yes or no? See, profit is what? Selling price SP minus the cost price. And what is loss? Cost price minus the salvage price. Consider a guy from who is selling newspaper. He has bought newspaper for ₹3. He is selling the newspaper for ₹5. And if his newspaper is not getting sold, still he is getting ₹1 in the form of salvage price. So if I ask you what is the profit from here, you will say, sir, profit is 5 minus 3, 2. If I ask you what is the loss over here, so loss is 3 minus 1, which is also 2. And if you ask me what is P by L, so it is what? P by P plus L, it is nothing but 2 by 2 plus 2, 4, which is 0.5. And this value you have to check between where it is lying. Now what is PS and what is PS minus 1? Suppose my dear friends, they have given you that this is the quantity and this is the probability. For one quantity, probability is 0.1. For second quantity, probability is 0.3. For third quantity, probability is 0.5. Let's say 0.4. And for fourth number of quantity, it is 0.2. The summation, it is coming out to be 1. Perfect. So second thing is, where is the cumulative probability? Cumulative probability. So this is 0.1. This is 0.4. You add this point. You add this. This is 0.8. You add this. This is. So my dear friends, our P by L ratio was 0.5, and we have to check that where is 0.5 lying. 0.5 is lying between over here. 0.5 is lying over here. So 0.5 will fall in this one. So your optimal order quantity is 3. That's it. See, with this example only, this is nothing but a kind of problem only. This problem, I have given one example and this has become a problem. So what is the answer? Which is your optimal order quantity? The optimal order quantity is 3 in this case, right? So in demand profit model, my dear friends, you have to remember only, okay, what is S over here? S is 3 over here. This is S and this is your S minus 1. That inequality I have written. So this is what? This is the cumulative probability. This is what, my dear friends? Cumulative probability. Yes or no? That's why I found the cumulative probability over here. So I think now there are no doubts regarding the demand profit model. And my dear friends, the final thing is service level model. The final thing is service level model. Service level model. My dear friends, again I will be asking you the same question, that can anyone tell me why I have drawn the curve of normal distribution when it comes to service level model? The same question as in network models I asked you, here also I am asking that why see, something must follow the normal distribution, then only I have drawn this diagram. Yes or no? something must follow it, then only I have drawn this diagram. Now what follows it is the thing. What follows it is the thing. If you know, you can answer in the chat box. Okay, so before coming to this, I'll be telling you some concepts. Suppose this is a basic EOQ model, and here I am keeping some safety stock. Here is the, see, in probabilistic model only we keep safety stock, yes or no? When there is uncertainty about the demand, we keep safety stock. See, this is what? This is the lead time. The demand rate is D, and this is what? The ROL. This is what? The Q. So if someone asks you, what is your ROL, the reorder level, you will say that, sir, it is this point, and that is nothing but demand rate into the lead time plus your service, your safety stock. Getting or not? Your safety stock. Now, my dear friends, this was a case. See, now listen very carefully. Listen very, very carefully. In this case, I have showed you that demand rate is also constant, lead time is also constant, and then I found ROL. But this might not be the case. Yes or no? This might not be the case always. Why? Because in probabilistic model, your demand rate may also fluctuate single-handedly. Your lead time may also fluctuate. Both can also fluctuate. Either way they can fluctuate by themselves, or both can fluctuate at the same time. And we have to take the average value. We have to take the average value, my dear friends. Now, I will be showing you few cases, and then it will be crystal clear to you, my dear friends. Right? See, let me show you when lead time is constant and demand rate is fluctuating. Suppose I am taking 3 cases. See, I'm trying to show that lead time is T over here. Here it is D1 demand rate, and here it is D2. Okay. Two cases are fine. So lead time is constant. Fine. So what will be the ROL? Okay. What is the average demand during lead time? So average demand during lead time is what? T into the average of this. T into D average. And what is D average? D1 plus D2 by 2. D1 plus D2 by 2. Done. Now let me take one case when demand rate is fixed and lead time is changing. Demand rate is fixed, lead time is changing. This is D, this is D. Now this is T1, this is T2. And now if I ask you, what is average demand during lead time, you will say, sir, D into T average. And what is T average? T average is T1 plus T2 by 2. This is the second case. So till now, my dear friends, whatever case I have taken, individually I have varied them. And now, my dear friends, I am trying to show that both are varying. This is D1, this is D2, this is T1, and this is T2. Both are varying. And here if I find what is the average demand during lead time, so you will say that's a D average into T average. That means the average of both the things. So you have to D1 by D2 by 2, T average, T1 by T2 by 2, T average. So all the cases only I have explained in this single screen. both constant, one either of them varying and both varying. From this definitely you can expect a good question. Now my dear friends, all this I have talked about not reorder level. I have talked for average demand during lead time. I repeat, average demand during lead time. Average demand during lead time. Please note this thing. Sir, how to get reorder level? You add safety stock. You add safety stock. You add safety stock, you will get reorder level. That is fine. Getting or not? And now I will come to my first question, that why I have shown this normal distribution. I'll again come to my first question, why I have shown this normal distribution curve. I'll come to this first question, that why I have shown this normal distribution curve. Something must follow. Something must follow. And my dear friends, the thing which follows the normal distribution curve is average demand during lead time. I repeat, average demand during lead time. I repeat again, average demand during lead time follows your normal distribution. Right? That means the demand during this period, it follows what? Normal distribution. So let me come over here. Now my dear friends, see, the demand during lead time, the average demand during lead time, immediately you will put it over here in the form of mu. In the form of mu. Now tell me one thing, do you know this expression? Z is equal to x minus mu by sigma. Yes or no? Yes or no? See, in 1 minute you will be able to say everything. In the next few seconds you will be able to tell everything, that what is what is what. See, this I can write what? Mu plus z into sigma. Getting or not? And few minutes back, what I have written over here? What I have written over here? That reorder level is equal to D into T is what? Average demand during lead time. Average demand during lead time plus safety stock. And now my dear friends, you don't have to do anything, simply compare. Simply compare. You can compare, right? So if you compare, X is corresponding to reorder level. Very good, sir. Mu is corresponding to average demand during lead time. Very good, sir. And Z sigma is corresponding to SS, the safety stock. Very good, sir. So what is mu? That's why I told that you can directly put mu over here, the mean. Mean will always correspond to what? The center curve. What is, say, if someone asks you what is safety stock? If someone asks you what is safety stock, you will say, sir, Z sigma. You will say Z sigma. Fine. These things are fine. Now the $1 million question is, what is Z and what is sigma? Z is the Z score. Z is the Z score. And my dear friends, why the name is there, service level model? Why this name is there? It is because Z is indicating the service level you want to maintain in your shop. I repeat, Z is indicating the service you want to maintain in your shop. For example, Z is equal to 0 is corresponding to a service level of 50%. Some standard values are there which will be there in your copy. Now, the next question, sir, how they are indicating the service level? Means there must be some value that, okay, the service level is given by this. Now Z equal to 0 is 50%. Can you tell that 50% means what? 50% is the area covered from 0 to left. So the area covered is only giving you the service level. That's it. Sir, getting or not? Z equal to 0, the area covered to the left is 50%. So 50% service level I have to maintain, that's it. Sir, suppose someone tells you that sir 95% service level I want to keep, then what? So you see that for what Z value the total area is coming out to be 95%. For what Z value the total area is coming out to be 90%, and that becomes your Z. That becomes your Z. Getting or not? So for any Z value, suppose sir over here Z equal to, you want to know that Z equal to 3 is corresponding to service level of what? You simply find the area of this curve till the complete area from 0 to that point, and you will get that much service level is being covered. So my dear friends, in exam if they give you 95% service level, they will give you the corresponding Z value, and from there you will be able to find the Z value. That is not the issue. That is not at all the bigger issue. So sir, what is the bigger issue? The bigger issue is, what is sigma now? What is sigma now? My dear friends, sigma is the standard deviation, everyone knows. Sigma is the standard deviation, everyone knows. But this is incomplete. This is incomplete. Then, so sir, what is complete? Complete is sigma is the standard deviation during lead time. During lead time. And if you are watching this video, I request everyone to just focus now. Repeat yourself that sir, why I am so much stressing over here? Why I am so much stressing on the fact that it is standard deviation during lead time, during lead time, during lead time. I'll be giving this with the help of example. I'll be showing you with the help of example. Suppose that for one day the sigma value is 2 and he is given you that lead time is 3 days. And if in that expression, sir, which expression? This expression, if you take sigma value as 2, gone. It is gone. Marks are gone. So sir, what is sigma? It is what I have wrote over here, standard deviation during lead time. So for lead time, now you will be saying that sir, for lead time that is on 3 days. So should we do 2 plus 2 plus 2? Should we do 2 plus 2 plus 2? Sir, you cannot add directly standard deviation. You have to convert it in variance, add, get the variance, then take the square root. For example, over here what is the variance? 2 square plus 2 square plus 2 square for 3 days. This is the variance, take the square root. This is your answer. So what you can write? Root over 2 square into 3 I can write 2 root 3. This becomes your standard deviation during lead time. And I request every one of you to not take this thing lightly, else you might be in trouble. So my dear friends, this is all about your service level, and if you have just, even if you do not know anything about service level, if you watch just this portion of 5 minutes to 10 minutes, things will be very much clear and it will help you a lot. So with this, my dear friends, our entire inventory is over. Our entire inventory is over. And now we'll be taking a break of 2 minutes, and then I'll be starting with a new chapter, mostly queuing theory, right? So just a break of 2 minutes and they'll be starting with queuing theory, right? We'll be starting with queuing theory. Fine. So welcome back, my dear friends. I again welcome you to this live session of the quick revision series on industrial engineering. So my dear friends, before the break, I discussed about two chapters, and those two were very big chapters, that is inventory and network models. And coming to continuing over that, the next the important chapter is queuing theory. It is queuing theory. So my dear friends, let us recall what are the basic concepts of queuing theory. In queuing theory, there is a queue which is formed. You can see this figure. There will be servers, people coming will be taking service, and they will be leaving the queue. Now my dear friends, let me tell you that in queuing theory, what is the most important thing that we study right from the beginning? It is that arrival follows Poisson distribution and departure follows, rather I should say departure time follows exponential distribution. I repeat, arrival follows Poisson distribution and departure time follows. Now I am saying departure time, all these things will be cleared in some time, and departure time follows exponential distribution. My dear friends, let me tell you that if these two distributions are clear, then you will, means I can say 50% of your queuing theory you will feel very much comfortable. This distribution, I will be starting this discussion based on this distributions only. What is Poisson and what is exponential distribution? My dear friends, very important. Now for the next 10 minutes, the things are very important, and if you are able to understand this, you will be benefiting a lot. Poisson's distribution, exponential distribution. My dear friends, what is Poisson distribution? So probability for any x is given as e raised to minus lambda raised to power x by x factorial, right? What is lambda? Lambda is, what is lambda? Lambda is the average number of events, average number of events, I can say. See, in this case it will be arrival, average number of arrivals we can say, but anyway, x is the probability for x, the probability for 2 arrival, the probability for 3 arrival, the probability for 4 arrival, whatever is there. My dear friends, you have also seen this formula. You have also seen this formula. Sir, which formula? This formula. Which formula? This formula. What is the difference between these two? What is the difference between these two? Now, you might be saying that, sir, this formula is used in maths and this formula is used in industrial. No, my dear friends. Yes, this is one good observation, that whenever a question comes in maths, we will say mostly it will be this formula, and in industrial mostly it will be this formula. But I must say you that this formula is nothing but, see, in place of t, what is over here? 1. Yes or no? So the above formula is for unit time, arrivals in unit time, and this formula is arrival in time t. Unit time means, so unit time is what? Per hour, per minute. So that is why in maths mostly you will be seeing the questions that find the probability of 2 arrivals in a given particular hour. Find the probability of 3 arrivals in a given particular minute, 1 hour. That's why mostly we use this formula. And when it comes to industrial engineering, you will be seeing questions like find the probability of 5 arrivals in a space of 45 minutes. T, 3 arrivals in t is equal to 45 minutes. Are you getting or not? Are you getting or not the difference? n arrivals in time t, 50 minutes, 30 minutes, whatever. Getting or not? So, if you have listened to this thing only, you will be able to differentiate between when to use this formula, when to use that formula. Now, Poisson distribution is giving you the number of arrivals, x arrivals. Now, can it be 5.5 arrivals? No, it will be always in terms of discrete values, 1 arrival, 2 arrival, 3 arrival, 4 arrival, and so on. But they also, now they ask question, now see, whatever in terms of arrival they ask you, you will be using Poisson distribution, that is 100% fine. And now comes the second factor, the second player in this game, time. They will be asking you, on an average there are 20 arrivals, let's say, and they will be asking you that what is the probability that the next arrival have to wait more than 5 minutes. Now the question has changed, and now they are asking you probability in terms of time. So always remember, time follows exponential distribution. Now whenever they are asking you in terms of time, we will be shifting to exponential distribution, and my dear friends, the probability for t is, just remember, lambda e raised to power lambda t, where t is greater than 0. Yes, this is the same thing. This is the same thing that we study in maths, exponential distribution. Now, what is t? The time. $1,000,000 question over here is, what is lambda? $1,000,000 question is, what is lambda? My dear friends, these are some of the very minute things, minute details that I am talking on. Lambda is the same thing that you have used over here. Yes, lambda is the same thing that we have used in Poisson distribution. But one thing is there, one concern is there. What is that concern? See, I'll tell you. Suppose they ask you lambda is equal to 20 per hour or 20 per hour or per minute, whatever. What is the probability that one person is coming and he has to wait for, let's say, he has to wait for less than 10 minutes, for example, less than 10 minutes. So you know, my dear friends, that if you want to find the probability for, let's say, less than 10 minutes, you have to integrate the density function. This is nothing but the density function, yes or no? So when you integrate the density function, see, less than 10 means, so I have already told t should be greater than 0, less than 10, so 0 to 10, and ft dt, in place of it is lambda e raised to minus lambda t into dt. You integrate and you will get an answer. But the $1,000,000 question is, sir, what value of lambda should we put? Let's say lambda is equal to, it is given 20 per hour. Should we put 20? My dear friends, you are finding t in terms of minutes. He has given he has to wait less than 10 minutes. And you will, now you are saying that, sir, can we put value of lambda in terms of hour? Sir, hour and minute, how can they stay together? No. That is why over here, mostly if they have asked you in terms of minute, lambda you will have to convert in terms of minute. For example, in 60 minute, if there is 20 arrival, so 1 minute it will be 20 by 60 or 1 by 3. So per minute lambda value is what? 1 by 3. Now you put 1 by 3 and get the answer. My dear friends, if you have only focused on this point, if you have listened to this just 10 minutes, 50% of your confusions should be over, because I know that this is the point where maximum confusions arise. Anyway, and if you don't have any confusion, very good. Now, my dear friends, so what is the thing? The thing is, now I can conclude very nicely, very neatly, that arrival follows Poisson distribution, departure also follows Poisson distribution, inter-arrival time follows exponential distribution, inter-departure time follows exponential distribution. That means whether it is time, whenever I am saying time, and whether it is arrival or departure, it will have to be exponential distribution. Arrival, departure, Poisson distribution. Getting or not? Getting or not? Getting or not? My dear friends, this is the coming to the second part. This is the Lee and Kendall's notation, and you have to remember that A is the arrival distribution, B represents service distribution, service time distribution. See my dear friend, sometimes you will see M something in this form. What is M, my dear friends? M is nothing but Markovian distributions. They are collectively called Markovian distribution. C is the number of parallel servers. D is the queue discipline. What is queue discipline? First come, first serve, last come, first serve, service in random order, general discipline. Whatever you want to take, you can take. What is the maximum number of allowed in the system? My dear friends, maximum number allowed in the system. Maximum number allowed in the system. It can be infinity. It can be a particular number n. It can be a particular number n. And based on this, my dear friends, we have to study two models. Mostly, questions are coming from this infinite model only, but there is a chance that can also come from a restricted queue length question type. And what is F? F is the size of the calling source population. My dear friends, that's a theoretical, and make no mistake, you can definitely get one question, a 1 mark question from this notations itself. And now my dear friends, coming to the most important part, coming model 1, where I already told you that M infinity 1, number of parallel servers is 1, GD means general discipline, infinity. The most important point over here, my dear friends, the most important thing over here is this infinity. That means maximum number of persons allowed in the system, and that is infinity. Maximum number allowed in the system is infinity, right? Now my dear friends, they will be giving you lambda as the arrival rate. They will be giving you mu as the departure rate. Now you have to find some performance parameter. See, whenever Q is there, you will be finding the performance parameters for that Q. You will be finding, means you will be excited to know that whether your Q is effectively working or not. That is why we define performance parameters. Yes or no? So the first performance parameter is service utilization. Service utilization or utilization factor, many things they call rho, and that is nothing but lambda by mu. Obviously lambda is less than mu. For a stable system, lambda should be less than mu. The second thing is, my dear friends, they will be saying you length of the system. They will be calling length of system. But before finding length of the system, let me tell you one thing. All this analysis is done for steady system. Steady system or steady state. And in a steady system, the probability for n customers in the system is nothing but rho to the power n into probability of 0 customers in the system. Very, very, very important formula, my dear friends. The probability of n customers in the system is nothing but rho to the power n p naught. Very, very important. You have to remember this thing. Now, the first question, sir, is this for number of Q? No, I told you, this is for system. So why you are using for Q? System. Always remember system. The second question, sir, what if they ask for Q? Convert it to system. If they are asking anything with respect to Q, we will convert it to system. Getting or not? Getting or not? Right? Now you will be asking me, sir, what is the relation between queue and system? Sir, let's say if there are 5 persons waiting in a queue, so there must be someone taking service, one person. So in your system there will be 6 persons. Sir, if there is one person only in the entire system, it means your queue length is 0 because that person is only taking the service. So queue, no queue, yes or no? Now my dear friends, let's talk about length of the system. But before length of the system, I need to know that what is this value of P naught. My dear friends, you know that in your system there can be 0%, 1%, 2% or infinity percent, yes or no? And the sum of all the probability of 0% in system, 1% in system, 2% in systems, 3% in system and dot 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 till infinity must be equal to 1, yes or no? So this is what P naught. Now from this steady state formula I can write rho P naught. For P2 I can write rho square P naught. From P3 I can write rho cube P naught and dot 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 is equal to 1, yes or no? So P naught, if you take common, it will be 1 plus rho square plus rho cube plus dot 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 infinity is equal to 1. My dear friends, if you add all this thing, you will be getting 1 minus 1 by rho is equal to 1. And finally, my dear friends, P naught you will be getting 1 minus rho. Yes or no? So what is the value of P naught? P naught is 1 minus rho. Now comes the question, what is length of the system? My dear friends, I am saying length of the system, but you should understand that it is what? You should understand that this is expected length of the system. Sir, you cannot find an accurate value, you cannot find a single value, you can expect something. See, it is all probabilistic model, it is all probability. So how can you make an accurate, find something accurately when there is probability? That's why it is called expected length of the system. Expected length of the system. Expected length of the system. Now tell me one thing, expectation, maths, random variables, everything is same. Expectation formula is what? Summation x into px, is or no? So either there will be 0% in system, probability. What is the formula of expectation? Summation x into px. Summation x into px, yes or no? Sir, what is the formula? X into px. I hope your maths is good, my dear friends. Do not ignore maths. X into px. Now x is what? 0%, 1%, 2%, 3%. What is px? Px is nothing but your probability. So 0% probability of 0 plus 1% probability of 1 plus 2% probability of 2 plus 3% probability of 3 and so on. So infinity percent, it will be infinity. No issues. So it is what? P1 plus 2P2 plus 3P3 and so on. My dear friends, I can derive the entire formula, but it is not useful at this point, and after deriving you will be getting rho by 1 minus rho. The length of the system is rho by 1 minus rho. Rho by 1 minus rho. Fine. The next thing is, what is length of Q? Again, I am writing length of Q, but in your mind it is what? In your mind it is what? Expected length of Q. Expected length of Q. Now my dear friends, you will be saying that sir, length of Q formula we have to find x into px. But suppose I am asking you one thing. Suppose if I write probability of 2 persons in Q or 3 persons in Q or any persons in Q, do we have any formula for probability of number of persons in Q? No. So what do we have? We have probability formula for number of persons in system. So I will try and convert number of persons in Q to number of persons in system. Getting or not? So if there is one person in Q, I'll be saying that there is. So suppose there is one person in queue. What will be the formula? Formula is summation x into px. One person into probability of one person. So I will be saying one person in queue means what? 0% in queue is what? 0. Forget about that. One person in queue, it means 2% in system. I will convert it into a formula of or problem of system. So 1% in queue means what? 2% in system into probability of 2 persons in the system. Suppose there is 2% in queue. So 3% in system into probability of 3 persons in your system. Getting or not? And so on and on. So it becomes what? 2p2 plus 3p3 and this. So mind it, p2, p3 are all but probability for system. And when you find all these things, when you derive all these things, my dear friends, I can do this, but it is not needed at this moment. So length of Q will come out to be rho square by 1 minus rho. And for students who have already have taught industrial engineering to them in the classes, they must be knowing that how this formula, all this is coming. Now my dear friends, length of the queue is fine, length of the system is also done, and now it's time for Little's law. Now what is Little's law? Little's law is giving you waiting time in the queue and waiting time in the system. What is waiting time in the queue? Waiting time in the queue is length of the queue divided by lambda. Length of the queue already found out, yes or no? Waiting time in the system, length of the system divided by lambda. What is lambda? Lambda is the arrival rate. Don't forget. Also don't forget that if they ask you waiting time in terms of minute and lambda you have substituted in terms of hour, so you have to mind it. Hour is there, you have to convert in minute by multiplying it 60. So all these small things, my dear friends, do not forget, right? Now my dear friends, I will tell you one thing. Let me tell you one thing. This much only you need to know. Whatever I have told you in queuing theory, this much only you need to know. But suppose when you go through different books, you will be finding some different probability formulas are there. See, you can do two things. First, you can memorize those formula, or you can trust yourself that whatever question they will give you, I will try to solve it with my basic knowledge. This you can do. For example, I will be giving you one example and things will be clear. I will be giving you one example and things will be clear. For example, if they ask you what is the probability of non-empty queue? 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 See, there is a formula. But how to solve it when you don't know the formula? I'll tell you. Non-empty queue means what? There will be one person in your queue or 2% in your queue. Yes or no? One person in your queue or 2 persons in your queue or 3% in your queue and so on and on. But do I know the formula for persons in queue? No. I know the formula for persons in system. So 1 person in queue means what? 2% in system. 2% in queue means what? 3% in system. 3 in queue means what? 4% in system, and so on and on and on. Yes or no? This thing I can write what? 1 minus probability of 0% in system plus probability of 1% in system and subtract it from 1. 1 minus P naught is what? 1 minus rho plus P1 is what? Rho into P naught. So 1 minus rho. Yes or no? Rho square is your answer. Rho square is your answer. So anywhere you will be finding what? Probability of non-empty, you will be memorizing like anything. Probability of non-empty cube, rho square, rho square. Nothing wrong in this, nothing wrong. You can memorize it. Yes, we need to memorize it, but even if you don't remember the formula, you can solve it using the basic concepts. Are you getting or not, my dear friends? So this is one thing. Another, my dear friends, you can always tell that what is the probability of your queue is your busy system, your system is busy, so it is nothing but your rho. What is the probability for ideal system? So you can always say that this is 1 minus rho. So all these things are fine, my dear friends, and as I said that based on this concepts only you will be able to guess the answer. So Harshil has just joined. What topics are over? So Harshil, we have already completed network, we have already completed your inventory, and now we are on the verge of completing queuing theory, right? So my dear friends, now whatever, you should remember one thing, that whatever this concepts I am discussing over here for queuing, this is for what? This is for when your system can take when there is no limit on your system. Remember, it's the model where there can be infinity number of customers in the system, but as I told you, there might be a case when they give you that only n persons are allowed in the system. That means there might be a case of restricted queue length. In that case, I have already shown you the formula on the screen, and you can memorize it, that it is, see, restricted queue length. Now I am showing that there is n persons in the queue in your system, sorry, and now in that case what is the P naught formula? 1 minus rho n plus 1. See, I will tell you how to get, no issues with that. Do we know this? Now probability for n is equal to 1. Do we know this, yes or no? So P naught plus rho P naught, using steady state formula, can I write this? P naught plus dot rho n P naught is equal to 1. Yes or no? So P naught I can take common, 1 plus rho square plus dot rho n is equal to 1. Yes or no? So what will be this formula? This formula will be 1 minus rho n plus 1 by 1 minus rho. Yes or no? So P naught, what we are getting? 1 minus rho divided by 1 minus rho. Got? Yes or no? Got? Now suppose you substitute 1 over here. So 1 minus 1 divided by 1 minus 1, 0 by 0. 0 by 0 is what? Infinity, indeterminate form. And whenever there is 0 by 0, what to do? Whenever there is 0 by 0, what to do, my dear friends? Whenever there is 0 by 0, what to do? L'Hopital rule. So when you see, this formula is only for rho is not equal to 1, and whenever there is rho equal to 1, you have to apply L'Hopital rule, and you will be getting what? This answer, 1 by n plus 1. 1 by n plus 1. 1 by n plus 1. Sirs, are you getting or not? Are you getting? So you know how it is coming, and you simply have to memorize the result. One more result I am requesting you to memorize. One more result is there, and I will request you to memorize it. Length of the system. And this one, you know how it is coming, you know how it is going to come, expectation formula. But just in this case, I am requesting all of you to memorize this, just in case if they ask, you should be able to do this, right? Length of the system. So you can take the screenshot, just to memorize it for the rote learning. This is simply rote learning, right? Either we can understand it or we can rote learn, fine. And my dear friends, let me tell you that with this we have completed the queuing theory also. So 3 very important chapters for GATE, each and every concepts in detail we have discussed. And now my dear friends, we can move on to our next chapter, and I think it can be our forecasting. Also, my dear friends, before I move on to forecasting, I would like to tell you that one sample problem of queuing theory, which I feel is very important to understand the chapter, I have included over here. So, either you can download the PDF after the session, or you can take the screenshot right now itself. And it is a very good question, my dear friends, and this I don't know why, but I feel that either in maths or in industrial or anywhere this can be asked. Okay, in this question, what I'll tell you what they have given. They are asking you that already 10 minutes have is over. Already 10 minutes I have waited, and what is the probability that a call will come in the next 5 minutes. So, already when 10 minutes is over, no need to means now you will think that sir, t is less than 15 minutes. T is less than 15 minutes given that 10 minutes is already over. That means it's a case of conditional probability question. No, actually this exponential distribution is forgetfulness in nature. It forgets everything. So, suppose 10 minutes has passed, it will forget that 10 minutes and it will count time from the present time to whatever time you are asking. So, 10 minutes is already over, he will simply take into consideration the next 5 minutes. That is why we have written this entire thing, but ultimately we are concerned with what is t is less than equal to 5. What is t less than equal to 5? So, again I felt it's a very good question, my dear friends, and it will clear most of the concepts, right? And as I told you, my dear friends, see, lambda is given as 12 per hour. Lambda is given as 12 per hour. You will be thinking that sir, in the formula of exponential distribution, let us put lambda equal to 12. No. What value of lambda they have put? 0.2. They have put lambda equal to 0.2. Why? Because minutes in minutes they are asking. They are asking the question in terms of minute. Why are you putting in terms of hour? Convert it in minutes and then put, right? So, I hope you have got the entire concept that I was talking about in the beginning, right? So, with this, my dear friends, let me take you. So, 3 chapters in detail we have discussed, and it's a very good thing. And now, my dear friends, see, before I move on to the next chapter, you might be wondering that sir, why we are not discussing LPP. See, in LPP there are no formulas. Number 1, there are algorithms, and algorithms can be understood with the help of numericals, and this is not a numerical session. Numerical session I have already taken. So, if you want to experience the in LPP, what comes? Graphical method comes, problem formulation comes, simplex method comes, transportation models comes, assignment model comes. All the problems I have taken in my concept booster session. If you want to get the feel of that, you can go and watch that session. All are algorithms. Getting or not? So, that will be clear only when you practice numericals, and this is a complete formula revision series. So, it is not a very good idea to take discuss LPP over here. Although if you get some time, I might be discussing some basic concepts. So, I hope you got the answer if there is any doubt. So, moving on to our next chapter, the next chapter is forecasting, my dear friends. The next chapter is forecasting. The next chapter is forecasting. My dear friends, in forecasting there are 2 types of method in which we can forecast. What are the 2 types of method, my dear friends? One is quantitative methods and another is qualitative methods. In qualitative methods, that means the methods which is based on human judgment. So, it is what? Market research, market trials, then opinion survey, and then the most important Delphi technique. In quantitative methods, what is there? In quantitative method, there is simple average method, moving average method, weighted moving average method, and then exponential smoothing method. And separately, there is one topic, and that is regression analysis. So my dear friends, you know that GATE generally favors numerical portion. So regarding the qualitative, nothing much to discuss. It is all about theoretical in nature. Yes or no? Now the most important, which I feel, is moving average to exponential. From here a question can come, and from here regression analysis one question can come. So my dear friends, let's discuss quickly what are these methods. Now moving average method. So I'll just give you one example and everything will be clear, my dear friends. In moving average method, see, you have to predict, you have to forecast. Okay. So suppose D values are given, that for month, let's say here it is month, here it is actual demand. So let's say for January they have given demand as 100, for February they have given demand as 120, for March they have given demand as 130, for April they have given demand as 140, something like this, my dear friends. And they are asking you what is the forecast for, let's say May. Let's say May, using the 3 moving average period. Means 3 moving average period. So last 3 periods I am going to concern. Yes or no? For May, if they are asking using 3 month moving average method, using this period, using this method, you calculate the forecast. So using the, I will have to take the simple average of last 3 months, 120 plus 130, 120 plus 130 plus 140 divided by 3, and that will become your answer. Getting or not? Suppose if they ask you what is the, using the 4 month moving average, so what I have to do? I have to just include 100 also now. 100 plus 120, 130, 140 divided by 4. Any number of periods they are asking, just add that and divide by the number, you will get the answer. Everyone knows, nothing much, no big deal about this. Now what is weighted moving average method? Weighted moving average method is, suppose the same example that actual demand they have given and forecast we have to find out. Suppose like say 100, 120, 130 and 90, something like this, and they are asking you, this is 1 period, this is 2 period, this is 3 period, this is 4 period, and they are asking you the forecast for the 5th period using weighted moving average method. Moving average method. That means we have to assign some weight to each of the periods. Yes or no? So how to do the weights? Suppose they will give you, let's say if they have given you, so it is very fine, it's easy. Suppose they have not given, in that case what you have to do? Suppose they are asking you 4 month weighted moving average method. 4 month weighted moving average method. So what I have to do? I have to simply write 1 plus 2 plus 3 plus 4. It is nothing but 10. Yes or no? Now divide by 10. Divide by 10. 1. So 0.1, 0.2, 0.3, 0.4 is equal to 1. So you have to assign the maximum weight to the most recent demand, which is 90 over here. Then decreasing weights, decreasing recency goes away. So finally if they ask you the forecast for the 5th period, so it is 90 into the most recent weight is 0.4. plus 130 into 0.3 plus 120 into 0.2 plus 100 into 0.1 and whatever is your answer. Getting or not? So this is weighted moving average method. Now my dear friends, you can always expect a question from exponential smoothing method. Every time we can expect a question from exponential smoothing method. In my opinion, that is the most important topic from this chapter. What is the formula, my dear friends? The formula is fn plus 1 is equal to alpha into dn plus 1 minus alpha into fn, right? Alpha is the exponential smoothing factor, value between 0 to 1, and demand for the previous period, forecast for the previous period. You can also write in this way, alpha dn plus fn minus alpha fn, and it can be fn plus alpha dn minus fn, and that is nothing but your error. That is nothing but your error for the previous period. So fn plus alpha into error for the previous period. You can also write fn plus 1. So two formula, within the two formulas you can use any of the formula, my dear friends, right? Now my dear friends, some of the theoretical questions are also being framed over here, that when we will take higher values of alpha, when we take lower values of alpha, we take higher value of alpha in case of a new product or in case of a fluctuating demand, and whenever we take low value of alpha, it is for stability. It is for stability. Yes or no? So all these things, my dear friends, I request you to just keep in mind. And okay, one more formula is there. One more formula is there, my dear friends. Let me show you. Yes, that is also there. So let me show you how it is coming. Let me show you. See, fn plus 1 is what? Alpha dn plus 1 minus alpha into fn. And in place of this fn, I can write what? Alpha dn minus 1 plus 1 minus alpha fn minus 1. Yes or no? So finally what I can write? Alpha dn plus 1 minus alpha dn minus 1 plus 1 minus alpha fn minus 1. Yes or no? So alpha dn plus alpha 1 minus alpha dn plus 1 minus alpha whole square, and in place of this fn minus 1 I can again write what? Alpha dn minus 2 plus 1 minus alpha fn minus 2. Yes or no? Alpha dn plus alpha 1 minus alpha dn plus alpha 1 minus alpha whole square dn minus 2. And now my dear friends, you can just something like this. It can go on and on and on. It means what? What is the basic idea for this? The basic idea is if they have not given you the forecast and everything they have given you in terms of demand, then this formula will become very much handy, right? So this is the thing. Now, regression analysis. Regression analysis. Why I have drawn like this? Because this concept is based on correlation and regression. Yes or no? This concept is based on correlation regression. Just a minute. Yes, my dear friends. So don't worry, I am here only. So my dear friends, what I was saying about that, why I have drawn this straight line, because this concept is based on because this entire topic is based on one concept, and that is line of best fit. What? Line of best fit. Suppose this is the original demand, these are the known values, no, these are the known values, and this is the predicted line, this is the predicted line that you have found out. So what is the error in this case? Error is d minus, suppose this predicted line, this is f, and that is you have assumed a plus bt. Okay, so what is the error? Error is d minus predicted forecast, d minus a minus bt. Okay, and this entire thing, error square, this entire error square you have to minimize. This entire error square you have to minimize. So that means what is your error function? Your error function is summation of, this is your entire error function. Okay, now tell me one thing, you know you have to find out the value of a and b. You have to see, in regression analysis there are two ways. F is equal to a plus bt. You have to know the value of a and b. You have to know the value of a and b. So directly there is formula for a and b. That is in your notebook. You will memorize it. That is fine. Suppose you have forgot it. Then what? Suppose you have forgot it. In that case, what you have to do? In that case, I am showing you one more method. See, how many variables are there? A and b. So if you differentiate this error function in terms of a, put it equal to 0, you will be getting one expression, na? 2 summation of d minus a minus bt into partial differentiation minus 1 equal to 0. Minus goes there and you will be getting with summation d is equal to a plus summation a is plus summation bt. So it is summation d is equal to, this is plus not t. So this is na plus b summation t. This is one expression. This is one expression. And one more variable is there, b variable is there. So if you differentiate the error function with respect to b and put it equal to 0. So what we are getting, my dear friends? 2 summation of d minus a minus bt into minus b is equal to 0. Yes or no? So just check. Sorry, this is t. This is t. So summation, minus gone there. So summation dt is equal to a summation t plus b summation t square. Yes or no? Yes or no? So this becomes your equation 1. This becomes your equation 2. Getting or not? Equation 1, equation 2. Two unknowns are there, a and b. If you solve these two variables, you can easily find out the value of what? You can easily find out the value of a and b. And once you find out the value of a and b, you can find out what is your forecast. Forecast, the line of best fit. So two ways are there. Once directly there is a formula for a and b. You can memorize that, and in case you have forgot it, you can differentiate it, get two equations, solve them, get the value of a and b, line of best fit. Error, if they ask you, you simply find out, error if they ask you, you simply find out d minus f. D minus f is your error. Now my dear friends, from error only I am getting one new thing, that they can ask you the possible types of error in forecasting. The possible types of error in forecasting. What are the different types of errors in forecasting, my dear friends? mean absolute deviation. Mean absolute deviation. What is deviation? Deviation is D minus F. Actual demand minus the forecast, D minus F. What is absolute? Absolute is mod, and when you take the mean, it is nothing but n equal to 0 to n summation divided by the number of periods. That is what? Mean absolute deviation. Second, what is mean square error? Mean square error. What is error? Error is D minus F. U square. See opposite, U square. And what is the mean? Mean is summation, entire summation divided by n. That is n equal to 0 to n. We will take 1 only, from 1 to n. That means you are taking the mean divided by n. Suppose they ask you what is mean absolute percentage error. Mean absolute percentage error. Mean absolute percentage error. So what is error? D minus F by D original into 100 percentage error. You take the absolute and finally you take the mean, which is n equal to 1 to n divided by n. Mean absolute percentage error. What more is there? What is bias? What is bias? Summation of D minus F divided by, take the mean with respect to, without considering the sign. Without considering the sign, you take the mean and you will get the bias, right? What more is there? Tracking signal is there. What more is there? Tracking signal is there. What is tracking signal? Tracking signal is summation D minus F divided by mean absolute deviation for that amount of period. That is also there. So these are the types of errors which is there in forecasting. And my dear friends, I would like to conclude this chapter with very important concept in error. Very important concept in error, and that is, like, suppose this is the actual demand and this is your forecasted demand and this is your error. Okay, let me take a new slide. Don't worry, let me take a new slide. This is your actual demand, this is your forecasted demand, and this is your error. This is your period. Let's say 1, 2, 3, 4, 5. Let's say you have values of this like 10, 20, 30, 15, 10. And this forecast value, let's say you have it from 20, or let's say you have from 30, and let's say you have from 5. Something like this. Something like this. Any value. They are asking you what is the mean absolute deviation. For example, mean absolute deviation or mean square error, whatever. I will be finding that only for 3, 4, 5 periods because I do not have the value for 1 and 2 period. This problem will arise, like they ask you that the forecast has been given with the help of 3 period moving average method. So using this 3 period, I will be able to calculate this. Using now these values, I will be calculating this, these values, I will be calculating. How will you calculate these two values? No, nothing. So until and unless they give you, if they give you, then it's fine, you will be able to find the error. If they have not given you, how will you calculate this error? We cannot calculate this error. Yes or no? We cannot calculate this error. So this will be left blank. I will be using calculating only for this last 3 periods. Very important, my dear friends. You can expect a question from here. Right? And my dear friends, and this is the end of forecasting, and like this we have discussed now 4 big chapters, 4 very important chapters in our industrial engineering, right? So I hope that no doubt is there, my dear friends. Next, my dear friends, let me take you to this very small topic, which is break-even analysis. So the figure itself says a lot of things. No, means I need not say a lot of things over here. This is the curve for total sales. This is the curve for total sales. This is the curve for total cost. This is fixed cost. Then this is your variable cost. This region is the profit. This region is the loss. This is the angle of incidence. Now, this is the point where they are intersecting, that is your break-even point. Break-even point, and then this is X. This margin, this is nothing but your margin of safety in terms of unit, and this is margin in terms of sales. So all these things are fine, my dear friends. So as I said, the figure is only telling you a lot of things. And when it comes to formula, let me write all the important formulas in forecasting, in break-even analysis. So what is total cost, my dear friend? Total cost is fixed cost plus variable cost, and that is nothing but fixed cost plus per unit variable cost into X. What is your total sales, my dear friend? Total sales is number of units into per unit sales. In general, if there is profit, it is fixed plus profit divided by S minus V, in case there is a profit. But in case you are finding only the break-even point, so profit is 0, so fixed cost divided by S minus V. Yes or no? This is 1, this is 2, this is 3, and this is 4. Fifth, there is a contribution margin. Contribution margin is S minus V. S minus V. Sometimes this is also equal to F plus P. Then there is profit to volume ratio. Profit to volume ratio. It is nothing but S minus V in terms of S. In terms of 1 minus V by S. 1 minus small v by small s. So all the formulas of break-even analysis I have written in this single screen, and there is no more formulas in break-even analysis, my dear friends. If you talk about line balancing, another important chapter, my dear friends, if you talk about line balancing, there are two important formulas. Line efficiency. What is line efficiency? Summation of the workstation time divided by n into the cycle time into 100. Yes or no? And second is, what is balance delay? So balance delay is 1 minus line efficiency. Always remember, suppose they have given you that 2, 3, 4, 5, 10 are the workstation time on respective stations: workstation 1, workstation 2, workstation 3, workstation 4, workstation 5. So what is the cycle time? The cycle time is 10. The maximum time is your cycle time, and this is where you can calculate the efficiency. What will be the efficiency? 2 plus 3 plus 4 plus 5 plus 10 divided by number of workstation is 5. 5 into 10 into 100. Balance delay similarly, right? Now my dear friends, break-even analysis I have discussed, line balancing I have discussed. In MRP, what happens in MRP? There are 3 inputs to MRP, right? There are 3 inputs. Out of those 3 inputs, questions come from bill of materials. Again, in bill of materials, in my concept booster session, I have already taken one question, and from there only you will be able to figure out that how to solve questions of bill of materials. So from that bill of materials questions come. So I have already taken that. Fine. So till now, what chapters we have discussed? Till now we have discussed network models, inventory, queuing theory, forecasting, break even, and line balancing. MRP is concept based. Regarding LPP, my dear friends, regarding LPP, I have already told you that it's a question which is full of algorithms. So it is better to solve questions rather me telling the concepts, right? But I can already tell you what are the important topics at the end. Now my dear friends, there is sequencing and scheduling. Yes, that chapter is also there, sequencing and scheduling. So that chapter is also there, sequencing, scheduling. So let me discuss something from sequencing, scheduling. My dear friends, in sequencing, scheduling, see again there are not many formulas are there in sequencing, scheduling, but there are small concepts and it's better to discuss these concepts. In sequencing, scheduling, there are two cases: n jobs 1 machine, n jobs 2 machines. The hottest part of this is n jobs 2 machines, in which there is Johnson's algorithm, and using Johnson's algorithm we find, see again that's an algorithm, there is no formula, right? I have already taken the question in my earlier session. But let me talk about n jobs 1 machine. In n jobs 1 machine, there is SPT. How many rules are there? Can anyone tell me? SPT, EDD, earliest due date. Then there is critical ratio rule. Critical ratio rule is already there. So see, this is a sample problem in front of you, my dear friends, and what happens? Already in SPT, see they have given me in some random order, I have arranged them in terms of SPT, shortest processing time. Flow time is what? You keep adding this processing time and you get the flow time, right? Due date they have given. What is tardiness? Tardiness is you subtract this from this. Flow time is 2, due date is 3. Any late? No. So you have to check that any late your product is getting delayed or not. Suppose in this case flow time is 9, due date was 6, so it is delayed by 3 days. So in this way you can calculate the tardiness. What they can ask you? They can ask you the make span time. What is the make span time? Make span time is 21. Make span time is 21. What is the total tardiness, my dear friend? Total tardiness 11 plus 7 plus 3, that is 18. 18 plus 3, 21 is the total tardiness. What is the average tardiness, my dear friends? 21 divided by the number of jobs. Number of jobs is 5, so 21 by 5 is the average tardiness, my dear friend. These are the small parameters, small things that they can ask you, right? Total tardiness, how many jobs are getting delayed? 3 jobs are getting delayed. So due date is there, flow time is there. So all this is small things. And suppose they ask you that using EDD rule find all the same things, so you will be able to do it very easily. What? In EDD rule you arrange the jobs as per the from lowest to highest due date. From lowest to highest due date. And if they ask you to calculate all these things, you will be very easily able to calculate. Yes or no? You will be very easily able to calculate. Now my dear friends, one thing, suppose if they ask you, we have to minimize the flow time. So generally the SPT rule minimizes the flow time and you can directly use that to get the answer. Suppose they ask you, we have to minimize the tardiness, the method which gives you the least tardiness. So in that case what we have to do? In that case, do not simply assume that EDD rule gives us the lowest tardiness and we apply that to get the answer. No, SPT rule might also give you the least tardiness. So in that case what we have to do? We have to calculate all the parameters, that means the least tardiness using SPT, using EDD, compare and get the answer. Getting or not? Getting or not? Yes. So I want to talk on critical ratio rule. Critical ratio rule. What is critical ratio, my dear friends? Yes, this is important. What is critical ratio? Critical ratio is time remaining divided by work remaining. So let me tell you what is time remaining by work remaining. Suppose today date is suppose today's date is 25th. Okay, let us take today's date only. Today's date is 19th. Okay, and I am saying that the due date for this is 25th. On 25th I have to submit one assignment, and the amount of work left is, work left in terms of processing time is 5 days. 5 days. Work left in terms of processing time means 5-day work is left. 5 days work is left. So what is the critical ratio? Critical, how much time is remaining? 6. 25 minus 9. What is the work remaining in terms of processing time? 6 by 5. 1 point something. 1.2. 1.2. Right? So this is how we calculate the critical ratio. So in terms of lowest to highest critical ratio, we arrange the jobs. We say that whenever critical ratio is 1, the job is on schedule. Whenever the critical ratio is more than 1, we are ahead of the schedule. And whenever the critical ratio is less than 1, we are getting delayed, behind of the schedule. So that is why we arrange the job in terms of lowest to highest critical ratio. So I hope things are clear in critical ratio also, and this is how we arrange the job. So my dear friends, critical ratio, and now when it comes to n jobs 2 machines, this is n job 1 machine. Now when it comes to n job 2 machine, in n jobs 2 machine there is Johnson's algorithm. As I said, it's an algorithm, and you know that the left hand jobs will come from enter from left, the right hand jobs will come from. So all these things you know, I need not talk much on that. All these concepts I have talked on in my concept booster series. And my dear friends, just one thing, that regarding LPP, if I want to talk on something, I've just taken one question so that you know, we discuss something. See, in regarding LPP, it is all about, if a question comes for graphical method, what we have to do? We have to plot the constraints less than or greater than equal to type. We have to see where there points of intersection, we have to plot the feasible region, and based on that we say that which is the maximum value or which is the minimum value, right? In this case, this is the feasible region, and this comes the answer, whatever comes the answer. Here it is unique solution, question can be multiple solution also. In multiple solution also things can happen, you can get multiple solution. And one suggestion is there, do not tick the answer of multiple solution just by seeing that the slope of the objective function is equal to the slope of one of the constraint. It should be the slope of the objective function should be equal to the slope of one of the binding constraint. What is the binding constraint? What is the concept of binding constraint? The constraint, the intersection of those two constraints with which we are getting the solution is binding constraint. In this case, this is the intersection of this and this is giving you the answer. So this is the binding constraint. Non-binding constraint is this one. So always remember that the intersection of the binding constraint only gives the answer, optimal value. And now when I am saying multiple solution, so the correct statement is the slope of the objective function should be equal to the slope of the binding constraint, then only we get optimal solution. Yes or no? So my suggestion will always be that in a graphical method question, do not simply see that whether slope is equal, so multiple solution will be the answer. Plot it and then check that which one is giving you the optimal answer. Regarding the see, this is the case of degenerate. This is the case of degenerate solution. What happens in degenerate? One of the decision variables becomes 0 value. One of the decision variables, suppose this is the answer over here. So x1 is 4, x2 is 0. So one of the decision variable takes 0 value. So that is the sign of degeneracy, and it also shows you that a redundant constraint is present. See, this is redundant constraint is present. What is redundant constraint? Useless constraint. You're right, useless. In this case, this is the useless constraint. So my dear friends, this is the case of redundant. Now in problem formulation, what happens? These are the types of solution. Unbounded solution is there, infeasible solution is there, that is you can very easily find out. Now problem formulation, you have to read the problem, formulate, write all the constraints by yourself, solve it using graphical method, and then check what is your answer, right? Now my dear friends, next comes the simplex method. In simplex method, once you have understood the algorithm, they will give you questions within the algorithm only, right? They will give you questions within the algorithm only. So just do one question of simplex. I have taken in my class also. If you have attended that, then no need to do outside of that. So very difficult questions you will not expect from simplex method. Yes, they can ask you that when does degeneracy happen. So degeneracy happens when there is a tie in leaving variable. So all these things they can ask you. What is the optimum criteria when c minus z is less than 0. All these things they can ask you, my dear friends. Then they can ask you what? Then they can ask you, they can give you duality of a function. See, all these things I have taken in my, repeatedly I am telling that all these concepts I have taken in my concept booster series. You can go and watch, you will be finding very nicely. They can ask you to find duality of a, primal dual. Questions can come from primal dual, that is also very important, right? Moving on to the transportation method, my dear friends, you know that there are two steps for a transportation problem. One, we find initial solution, then we find optimal solution. For initial solution, there are three methods. What? Northwest corner, least cost method, and Vogel's approximation method, penalty method. Optimal solution, MODI method, modified distribution method. So among the initials, initial solution methods, the VAM method is very important, and you should always focus on VAM method, right? VAM method question can definitely come from VAM method. No, least cost can also come, but VAM method is very important. Now, MODI method, see, question still now have not a full length question has not come on VAM method, but things can definitely come, right? So you can just solve a question from VAM method and get the answer, know the concept. And moving on to, okay, there is degeneracy in transportation. So these are some of the difficult, not difficult I want to say, but some of the untouched topics in industrial. So although if you have attended my class, I have already discussed degeneracy in transportation, looping in transportation. My dear friends, yes, from looping I got to understand I remembered one thing, that what is the optimum allocation? M plus n minus 1 is the number of optimal allocation. Please remember that. 1 mark question can definitely come. Number of rows, column, M plus n minus 1, number of optimal allocations. If the number of allocation is less than M plus n minus 1, what do we say? If it is greater than M plus n minus 1, what happens? Can anyone tell me? If the number of allocation is less than M plus minus 1, degeneracy takes place. If it is greater than M plus n minus 1, looping takes place. Okay, looping takes place. Suppose there are 10 allocations and the value of M plus n minus 1 is 8. So how many loops are formed? 2 loops are formed. So 1 mark question can come from here. Yes. So all these things are fine. Now in assignment, yes, Hungarian method is there. A straight line method, very, very important, my dear friends, and very beautifully I have taken a question in my concept booster series, and we have discussed very neatly. So in LPP, as I told, my dear friends, there is so many algorithms. So if you have studied, you have studied. There is no formula as such apart from these two. So my dear friends, only this much is there, this much was there in our session, and this is what if I try to recap what we have done. We have discussed network, we have discussed inventory in detail, we have discussed queuing in detail, we have discussed forecasting, price break model, then break even analysis, then MRP, then line balancing. Finally, I also told you regarding sequencing scheduling, I also told something about LPP. And in this 3 hours, my dear friends, if you have listened it nicely, I am sure that you are going to benefit a lot in your examination. Yes, some portion of LPP is algorithm based, so that is only possible with the help of your questions only, question practice only. But as I told you that only 10 days hardly is left for your GATE examination, and my advice is, please do not touch anything new. Whatever you have studied, have trust in yourself and keep on revising those things only. In case of any doubt, we are there with you. You can, in case of any doubt, particularly from my session, you can leave any doubt in the comment section and I will personally reply it you, right? So my dear friends, I am not going to waste your further time. Please revise. All the best. Have faith on yourself, on your abilities, on your hard work, and we are always there with you. So with this note, my dear friends, I am going to end the session. My best wishes are with you. Thank you very much. Take care.